This is part 3 of section 6.3. We're still solving triangles. We're still supposed to round to the nearest tenth, but now we're moving on from side angle side problems to side problems. And in a lot of ways, these are easier because you do not have to use something you've computed to find the angles. So we can actually get very exact answers and not have to worry about using memory as much. Okay, so in this case, we are given side A, side B, side C, and we're asked to find angle B. So if we're asked to find angle B, then this is the formula we need to use. So I have B squared is equal to A squared plus C squared minus 2 times A times C cosine of angle B. Okay, so just like on the previous problems, I'll end up with cosine of B equal to 4 squared minus 3 squared minus 6 squared divided by negative 2 times 3 times 6. And you get that cosine of B is exactly 29 over 36. Take the inverse cosine of that answer to find that B is approximately 36 point, we're supposed to round to the nearest tenth, 3 degrees. And since that's all we were asked to find, we're done on this one. If we were asked to find our other two angles, I would use either this formula or this formula to find either A or C, and then I'd use the fact that they all need to add up to 180 to find the remaining angle. Okay? So let's work this one, and we're supposed to just find angle A. So I will be using this formula. So I have A squared is equal to 3 squared plus 5 squared minus 2 times 3 times 5 cosine of angle A. Okay, so I end up with cosine of A equal to 2 squared minus 3 squared minus 5 squared divided by a negative 2 times 3 times 5. And we get 1. Inverse cosine of that answer gives me 0. Okay, so 0 degrees, or our other possibility would be 360 degrees minus 0. But I cannot have an angle of 0 degrees and have a triangle. I can't have an angle of 360 degrees in a triangle. So this is no solution. This cannot happen for a triangle. So they say that there is no such triangle. It's impossible to draw a triangle with that length of sides. Okay? So now let's solve these triangles. And we're going to find all three missing angles. Okay, so we have side A. I'm going to write my sides on the left here just because we already have those. And we need to find each of our angles. Okay, so to find angle A, that's going to be A squared is equal to B squared plus C squared minus 2 times B times C times cosine of angle A. So we get cosine of A equal to 11 squared minus 13 squared minus 16 squared over negative 2 times 13 times 16. Okay, and I get that it is exactly 19 over 26. And then if you find inverse cosine of that, you get that A is approximately equal to 43.0490798. I'm going to put that in memory just so that I can use it later to calculate the missing side or missing angle, and I'll have it exact. I'll come back to that later. We're supposed to round our angles to the nearest tenth, and you get that A is approximately 43.0 degrees. Okay. Now I'm going to find angle B. Theoretically, since you have this now, I could use the law of sines to calculate the next angle if I wished, but I would have to be careful about not using this approximation in my calculations. If I'm going to find angle B using the law of cosines, I will have 13 squared is equal to 11 squared plus 16 squared minus 2 times 11 times 16 times cosine of angle B. So cosine of angle B is 13 squared minus 11 squared minus 16 squared divided by negative 2 times 11 times 16. And I get that that is exactly equal to 13 over 2, and I don't think that's right. What did I do wrong? 13 squared, A squared, 16. Oh, I entered 1 here and not 11. So let me go up and change that. Okay, so that's exactly equal to 13 over 22. Now, why did I know that I made a mistake? Because the previous answer I got was larger than 1, and if you take inverse cosine of something larger than 1, you get an error. Now, if I find inverse cosine of that answer, I get that my B is approximately this, which rounds to 53.8 degrees. Okay, and then to find angle C, I'm going to do 180 minus angle A minus angle B. Okay, so 180 minus this answer, which was exact, minus what I put angle A in memory. So angle C is approximately this, which we need to round to the nearest tenth. So that is approximately 83.2 degrees.